Welcome to the Meniscus Energy Efficiency Dashboard. This is a Silverlight application that runs in a conventional web browser, and it has been designed more for the water industry, but it can be applicable to any other industry. But where people are looking to understand the performance of combinations of pumps and how efficiently those are running and when they should be running. So this is more geared towards large pumping set applications and monitoring and targeting of large pumping sets than the smaller pumping sets. Though, as I say, it can be applicable to anything. What we're trying to do on this dashboard is to present all of the information that a knowledgeable user would need in order for him to be able, or her, to be able to set a particular target for a particular set of pumps or combinations of pumps. So that's what we're trying to do and deliver that. And then at the back end of this, which is delivering all of the calculated metrics, is our core calculation engine, and which is delivering all the actual calculations, and our PC client application can be used to actually configure all of this data over the web. So what we've got here is we're looking here at pump combination 4. So this is we've got overall a 7 pump a group of pumps which has 7 pumps within it. So pump combo 4 is pump 1, 3, and 13. These are all odd numbered pumps, and these 11 combinations of pumps actually represent round about 90% of the combinations of pumps that are used on this particular site. So what we can do, this little graph here, we can use to select a range of data. We'll see that in use later on. So if I click this right arrow, we'll actually see that this is over this 2-month period. This is when all the time that the pump combination was in use. This combo 4 was in use. The grey figure is the actual kilowatt hour per megaliter value, and the red is our target. And you can see that the match is pretty good, and there's a lot of data filtering going on in the calculation engine to make sure that actually we do all the calculations at the right time, using the right data and the right sets of data to do that, so that we actually get all the spikes coming in at the right time, and then everything's working out. And all of that is automated. So that's all automated. So everything you see here is what a user would see. They would not have to do any of the configuration or data processing behind this. This is all delivered data to them. So we can then look at a range of information. So these are all benchmarks which have been set up for this particular site. So again, by using these windows, we can actually change these. You can select which set of data we want to look at. But let's just say we'll select all the data. And you can look at this, and straight away you can see that we've got good information on these sites, and in terms of kilowatt hours per megaliter, meter head. We can shrink that down. These are some key performance metrics. This is the actual price, energy cost of delivering this water. So this is in pounds per megaliter, and this is using real tariffs. So real tariffs which are multi-day tariffs, so different rates for different periods of the time, for different day types, and actually different seasons as well. So quite complicated electricity tariffs. This is all modeled within the calculation engine and all set up. That's relatively straightforward to deliver that. So this is giving you the pounds per megaliter for each of these combinations of pumps, and we can straight away see combo 5 rather is our lowest cost combination of pump, which is for the combinations that are running during this 2-month period. I'll just put this filter on which gets rid of that bottom one, which has got nothing. So that's our KPIs. We have normalizers, so we decided those, and we'll see why we call them normalizers, but effectively they're just used to set the x-axis for the regression analysis. So we can select any number of those. We've got 2 here. We can select from one of those. We have actually all the targets themselves. This is all the graphs that we're seeing up here. We can display those. This is the actual power for the site. So these are the pumps that have actually been in use, and the grey line is the average value over this. So this little sparkline graph, the grey value is the average data over that time. So you can get a quick idea of what the actual relative values are for these sites. And straight away you can see that we've got 5 pumps that have been operating in this 2-month period. Hence we don't have all 11 combinations showing. So if I choose a normalizer, we can then load a regression graph, and this regression graph is now doing a regression of this grey data, which is the kilowatt hour per megaliter data. So this is up the y-axis, and on the x-axis we have the total flow, which was selected from this option here. and we could have chosen power if we wanted to. And if we want to exclude some points, we can exclude those first 2 points. They're the lowest values on the flow graph. We can update that grade data, and that effectively is the target equation, or polynomial equation. Now we will be adding linear regression, which is obviously quite straightforward, but we'll also be looking to add multiple linear regression and multiple polynomial regression here as well. So we should at some stage be able to do much more complicated targets based on flow and pressure, for example. But effectively, by pressing the set as target button, we will use this equation, and it'll update the calculation engine with that new target value, and that equation will then be used in all future calculations of that target for this particular combination. So as a consequence of doing this, what we'll actually end up over time is we end up, by doing this on a regular basis, on a 6-monthly basis, for example, reviewing these targets, we will generate different curves, combinations of these curves, and that'll give us an idea of how the plant is, this particular combination is degrading with time. So we would expect that this plant combination, as it degrades, would actually come slightly lower and lower and lower, as we should be able to see that over time as well. So that effectively is the analysis that we've got available within each of the individual combinations. And remember, all this data is derived in the calculation engine, and what we're doing here is using all this data to be presented to enable us to define when we want to set the target. So if, for example, we said, right, actually I only want to set this target, this data was not relevant, so I just want to apply the target over this 3-week period, then we could update the regression graph, and that's the regression graph based on this 3-week period of data, and so that's the purpose of that. We're identifying savings as well. So these are savings. So these, where you see the blue spots here, are actually when the savings go negative, which that does happen occasionally, as you see. But more often you've got positive savings. So that's when the actual consumption is greater than the target. So there are savings to be had here by optimizing the plant combination a little bit better. And we can then use those savings and information to actually identify opportunities. And what we've tended to do is to say, so I've still got a savings graph, so I've got combo savings 4, so let's take that out. So what we've got here is this is collating all the savings data in saying, on a daily basis, what is the amount of savings that we could achieve if we had optimized this particular combination of pumps, of this combo of pumps. So we've got a value here, and we can derive that. So about an average of 1,000 kilowatt hours per day over the 2 month period. What we can then do is we can aggregate all this information up into a plant group level. So at the plant group level, you're saying this is the performance for the group of pumps. Now, unfortunately, we can't get rid of this regression graph at this moment, so please bear with me on that. But effectively, again, we've got the same information as we had before. The grey is our actual consumption data for our actual value of kilowatt hour per megalitre for the group of pumps. So that's a derived value. And the red line is our target. So that's where we want our combination to be, our overall group of pumps to be working. And again, the same process can apply. We can set the regression analysis, so we can work out regressions at this level, and also regressions at this level. And we can then display that in terms of overall opportunities. So this is now collating data for all of the plants, all of the plant combinations. So we're aggregating all of the individual opportunities up into the group the plant group, so saying this is the actual overall saving for the whole of this plant group. So out of all these the pumps that have been running within this group of pumps, over a year we would actually have saved £40,000 if we had applied if the site had used the best combination of pumps to deliver a particular flow, and constantly changed to use the lowest cost combination pump combination. So that's effectively what we're trying to do here, is we're trying to identify and deliver these opportunities to plant managers so that they can get their operators to change the combination to the best performing combination for the relevant flow. We actually have ranking algorithms that can deliver this data. So if I just shrink these and expand this a little bit. So this actually is saying this is the best combination of pumps. So we can say when these plants, when the combination is when you have that best combination, and you can actually just see that there is a straight line roundabout, or there's a line roundabout here, which is quite common, which is plant combination 5, and that was the combination you may remember was the overall lowest cost combination of all those combos of pumps. So effectively what we're doing here is we're just to reiterate, we're working out all the metrics at the combination plant, the pump combination level. We are then aggregating that data up into a group level, which can be aggregated to a process level, which can finally be aggregated up into site level. So at different levels we are able to show potential opportunities, cost-saving opportunities, and to summarize those up into a site level, so that we can report and make sort of macro reporting for managers much easier. So hopefully that gives you an idea of what we're trying to deliver with this dashboard. It's quite complicated, but we'd be very happy to come and talk to you about it and how it can apply to your business. If you have any questions, please give us a call, and all our contact information is on the Meniscus website. Thanks for your help. Bye.